Okay, well, in that case, we'll continue on. Or I don't know. Before I continue on, are there any questions or concerns, feedback, comments? We're good? Okay. All right, so we're still talking subsetting, and now we can talk about subsetting matrices and arrays. And you can subset a higher dimensional structure in three ways. You can subset it with multiple vectors, or with a single vector, or with a matrix, okay? So probably the most common way of subsetting a two-dimensional matrix is you supply a one-dimensional vector for each dimension, right? So probably the first one, multiple vectors, is probably the most common way, and so blank subsetting is very useful because it lets you keep all rows or columns. But we'll take a look at all of these things, okay? So here, A I'm going to set up as matrix 1 through 9 with 3 rows. So you can imagine that filling out, 1, 2, 3, 4, 5, 6, 7, 8, 9 down the columns, right? And we can call, we can give it names, columns A, B, and C. And so if I say I want to subset A using 1:2, then a comma, then it will select rows 1 and 2. And then the comma blank means select all the columns. Okay, so the 1, 2 corresponds, this vector corresponds to the rows which we are selecting. And over here, this corresponds to the columns that we are selecting. Over here, the first vector corresponds to the rows, so that means true, false, true would be select the first and third rows. And then as far as the columns that we select, we would say select column B and column A. And so that gives me B and A for the columns, and then the rows will be the first and third rows. Okay. Or I could say select none of the rows, 0, and then select the columns that is not the second one, so exclude the second column. So that gives me just the names A and C, but none of the actual values. Sorry. Okay, but you guys are probably familiar with this form of subsetting here, where you just kind of provided a numeric vector for the first row, or for the rows and for the columns, and select your subset your matrix that way. But you can provide it logical true false vectors and things like that to correspond to which rows you want. Okay. By default, using the single square bracket will simplify the results to the lowest possible dimensionality, and we'll talk later about how to avoid this using preservation. Okay, so if we say is A a vector, that's false. A is not a vector, it's a matrix, right? But then if I subset A to just select the first row, and it gives me back 1, 4, 7, it has reduced A down to a vector, okay? A subset to just the first row is not a matrix with one row and 3 columns. It is a one-dimensional vector, right? So that, depending on maybe your programming background and what other languages you've experienced, that may or may not be expected behavior, okay? Because A is originally a matrix, and we just said select the first row, and rather than returning a matrix with 1 row and 3 columns, it returns just a vector with 3 elements in it. Okay? And that's the default behavior of your single bracket subsetting. You can avoid that by during when we talk about preservation. So it says, because matrices and arrays are implemented as vectors with special attributes, you can subset them using a single vector. Okay, so we finished talking about subsetting with multiple vectors. Now we can talk about subsetting with just a single vector. So here I've got a character matrix, okay? 25 elements, and each thing is just kind of the coordinates here, right? And so if I say select the 4th and the 15th, notice there's no comma here. It just says subset the matrix vals, selecting the 4th and the 15th items. It's going to select the 4th item, which is 4, 1, and then counting them out, the 15th is going to be this one, 5, 3. Okay, so here it's just treating it as a kind of a one-dimensional vector where everything fills out by column, and then it says select the 4th and the 15th elements. Is that okay? This thing was created using outer. Outer is it's like an apply function, but basically if you outer multiply two vectors, it's going to give you a matrix, okay? Because it uses one vector as kind of the column and the other vector as the row, and then it applies the function that you provide. And in this case, we're providing it the function paste, and it's saying take, for the column, take the 1 over here, and then take the 1 over up here, and then paste those together. But you could give it a different function, such as multiplication. That's actually the default behavior, is to just do outer multiplication, and it would take each vector and create a matrix of all of the products of all of those things. So you could create a times table very quickly just by doing 1 through 10, outer multiplication 1 through 10, and it creates your times tables, your 10 by 10. Here, I'll just demonstrate that real quickly. Or maybe that appeared in your homework already, I don't know. If I do 1 through 10, and then the shortcut for outer multiplication is %O%, 1 through 10, and that's your times table. So this could have been handy in 3rd grade. So there you go. Okay, so that's, you can select, subset a matrix using just a vector of single values. Okay, and then lastly, we can subset a higher dimensional data structure with an integer matrix, or if named a character matrix. Okay, each row in the matrix specifies the location of one value, and each column corresponds to a dimension in the array being subsetted. So you can subset a 2-column, use a 2-column matrix to subset a matrix of 2 dimensions, or a 3-column matrix to subset an array of 3 dimensions. Okay, so for example, if we go look at our vals thing, here it says select, so notice I'm doing by row equals true, so this is going to be my first row, the second row, and the third row. Okay, so here I've got 3 rows. Each one of these rows is going to be a value that I select. So this one says select, your first item you're selecting is first column, first row, first column. This is third row, first column, second row, fourth column. So it's going to select elements 1, 1, 3, 1, and 2, 4. It selects this one, and this one right there. Okay, so it selects using basically you're providing it a list of coordinates in your 2-dimensional matrix, right? Because otherwise trying to just select these 3 values in any other way would be quite challenging. And here I've generalized this to an array. Okay, so with an array I've got the elements 1 through 12, and we've said there's 3 dimensions, 2 rows, 3 columns, and 2 layers. And so each value in this array is defined by 3 coordinates, right? So now I'm providing it a list of 3 coordinates to select the values. So if I say select the value at 1, 2, 1, that's going to be the value at the first row, second column, first layer. So that's going to give me 3. And then over here it says second row, third column, second layer. Second row, third column, second layer is going to give me 12. So it gives me back those 2 values that I've specified using those 3 coordinates. Do you have a question?
Yeah. So this function will automatically identify the three digits which fits with the dimension of the array, and then it goes on to the second layer of the array, right? Because it seems like you put 6 digits together without like specifying which one belongs to which layer.
Well, this is a matrix. It's a matrix of 3 columns. So this is a 2 by 3 matrix. And so when you pass, so this is the subsetting operator, right? The single square bracket. Okay? The single square bracket can receive a few different things. It can receive multiple vectors. That's probably the most common way. It can receive a single vector of just integer values. Okay? And then lastly, you can also pass it a matrix. Right? So if I passed it a matrix of different dimensions, it will error out. Okay? It will say, like, you know, your array has three dimensions to it, and you're giving me a matrix with four columns or something. It's gonna say it can't do it. So it recognizes you've given it a matrix with 3 columns and 2 rows, and so it says, okay, those 3 columns correspond to each a coordinate value, and then those 2 rows are the 2 different values you want me to extract. Okay, does that make sense as far as this thing goes? Matrix, using a matrix to subset an array or a matrix. Okay. Data frames possess the characteristics of both lists and matrices, and so if you subset with a single vector, they will behave like a list, and if you subset with 2 vectors, then they'll behave like matrices. Okay, so here I'm creating a data frame with 3 columns, x, y, z, and 3 rows, okay? And so I can subset like a matrix using two vectors here. One of the vectors is empty, so that means select all the columns. But the first vector is a logical vector which will only give me true values for when x is equal to 2. Okay? So when it looks at df $x and it says which one is true, it's going to give this logical vector will evaluate to false, true, false, and so it will select only the second row, which is this one. It will only select the row where x is equal to 2. And then because I gave it an empty, provided it nothing here, it will select all the columns. Okay? Here I'm saying select the rows 1 and 3, select all the columns. And so it selects the first and third rows and selects all the columns. Over here, I have no comma. I give it one vector, x, then z. Okay? That's one vector. There's no comma, so, or comma before or after. So this is not going to, it's not looking at which rows or something like that, but now it treats df as a list. Okay, it's treating df as a list. And so the underlying list, what are the elements in this underlying list? There are 3 elements in the list, and those are the named vectors x, y, and z. The first element of df, so if we look at this data frame here, okay, and then so if I say what's the structure of df, it's a list, well, it's a data frame, but internally it's a list, right? And it's got 3 things, and so now when we specify x and z, it's going to select the list element x and the list element z. And so we get back a data frame with just those 2 columns, x and z. Okay, over here, we can select the columns as if it were a matrix. So now it says select all the rows, comma, and select the columns named x and z. Okay, and it says there's an important difference if you select a single column. Matrix subsetting simplifies by default. List subsetting does not. Okay, so if I if I do df with a single bracket, with no comma x, it's still in the form data frame, whereas if I do comma x, it simplifies it to, what do you call it, a vector, right? So if I look at data frame, so this is my entire data frame. If I say data frame, just select x, this returns it as a data frame, right? This is much like subsetting a list, where if I do data frame, select all the rows, but where the column is just x, it simplifies it to a vector. All right, so here we got some tests here. Okay, what's going to happen if I try to do this? Empty cars, where empty cars, the cylinder column is equal to 4. So just so you know, empty cars is a built-in data set here. Motor trend cars, it's like one of the default data sets that we have. Okay, and so it's got these columns and cylinders, a bunch of different cars, 4 cylinders, 6 cylinders, 8 cylinders. So I got empty cars, cylinders equals 4. So is this going to be a problem? So this won't work because I've got single equals. What we need is we need to have double equals. Okay, double equals for a logical test. Okay, and then when we do that, then it will select all the rows where this thing is true, and so that will give me back all the rows where cylinders is equal 4. Okay, and if I do empty cars, -1 through 4, what's going to happen there? It's not going to work because I'm mixing negative and positive values as far as which rows to select, so that won't do. So if I just say 1 through 4, then it will select the first 4 rows. Here I've got a logical test here. Empty car cylinder is less than or equal to 5. What's going to happen there? Or not what's going to happen, but what's wrong with this thing? Here I have no comma, right? I have no comma, so what it's going to do is this is going to be giving me back true and false, a true and false vector corresponding to which rows are satisfied true, so it'll be like false, false, true, okay? But if I'm selecting it just like this for a data frame, then it's going to select kind of the columns that correspond. So I need to specify the rows by throwing in that comma. Let me just kind of show you what might happen if I do empty cars, where empty cars $cylinder is less than or equal to 5. Okay, well it says undefined columns selected, but basically if I give it something like false, false, true, then so here it's recycling that and it's going to select the 3rd, 6th, and 9th columns. So it'll select the 3rd, 6th, and 9th columns there. Okay, but basically I'm also, with empty car cylinder less than or equal to 5, I'm giving it a vector that's like, you know, has 20 elements in it or something, and it only has 11 columns. So when it gets to the kind of the 20th true or false value, it says you're trying to select an undefined column. Okay, here it says with cylinders equal to 4 or 6. The problem here is that the OR operator needs to have true 2 logical statements to compare, okay? So when you're comparing this empty car cylinders equal to 4 is going to be a bunch of trues and falses. Empty car cylinders will be a bunch of trues and falses. And then you can do an OR operator between trues and falses. Back here, this is going to be a bunch of trues and falses, and this is just a 6. Okay, so now you're giving it select true or false, true and false, or 6, okay? And so it doesn't quite know what to do, right? So let me just see what happens if I do true or 6, okay, false or 6. So basically this is what we're doing. We're giving it trues and falses and then a 6, and so this is going to no, undefined columns, let's do space. So this has selected all the rows because when you say you got true or false or 6, the 6 kind of gets coerced into true, and then it's always going to be true. Okay, so you need to have 2 separate logical vectors. Okay, and then if I do empty cars 1 through 20, I think we kind of hinted at this. This is going to give us undefined columns selected because there's only 11 columns, and and it's trying to select the first 20 columns. We have to either say, you know, give me the first 20 rows, or something like give me the first 6 columns, or something like that. Okay. All right, let's talk about lists. And subsetting a list works in the same way as subsetting an atomic vector. Using the single square bracket, we'll always return a list, and using the double square bracket or $, as we'll describe next, lets you pull out the components of the list. So here I'm defining a list D with the elements A, B, and C, A being a numeric vector, B being a logical vector, and C being the character vector with just one element A, and we can look at the structure of D. Okay? If I do D single bracket 1, then it returns a list where the it's going to be a list of 1, and where the first object in that list is a numeric vector with the numbers 1, 2, and 3. Here I've got a recursive list, and I said L1 is a list, and the items in that list is a list with itself as another list where the first object is the numeric vector 1 through, or integer vector 1 through 3, and the first 4 letters of the alphabet, and then the integer vector 1 through 5 is the second item. So the structure of L1 is a list of 2. The first thing is a list, and the second thing is an integer vector, and then inside that list we've got, inside that first list is an integer and character vector. So if I subset L1 and ask for what is the first thing in that list, it's going to return back this part, the list of 2 of 1, 2, 3, and A, B, C, D. If I use double bracket, okay, notice that when I use the single square bracket, it gives me, it's not the list, it gives me back the first list item with where the first list item is itself a list. So I got the double square 1 and the double square 1 again, and so this is to say the first list item and then the second object in that first list item. Whereas if I use the double square bracket here, it extracts that and it returns back the list that's inside the list. Okay, so it's a little bit funny, but when you use the single square bracket, basically it's going to just say list of 1, and it's this top part up here. When you use the double square bracket, then you actually get this, just the internal list without the outside list structure. Okay, well, maybe I'll illustrate this a little more. Okay, if I use double square bracket 1, okay, which gives me back this, and I say, what is the second object in there? It's the list. It's a list item where the first thing is a character vector A, B, C, D. And then if I say, what's the second thing in this thing? It gives me back null. The reason why it gives me back null is because there's no second list object. It's a list of just one thing. Okay. Whereas if I wanted, if we're trying to get this letter B here, I have to say, use double square bracket 1, double square bracket 2, which will be the character vector, not the list of one item where the first item is a character vector. It's going to be just the character vector. And then lastly, then I could subset that character vector to just the second item or element, which is the letter B. Is this okay? The difference between the single and the double square bracket for subsetting a list? Okay, and so here's this kind of the illustration here, right? So we've got the subsetting operator with the double square bracket and the dollar sign. Double square bracket is similar to the single square bracket, except it can only return a single object and allows you to pull pieces out of a list. Okay, dollar sign is just a shorthand for that when you have character named lists. Okay, so you need the double square bracket when you're working with a list, because when you use the single square bracket to a list, it always returns a list, and it never gives you the contents of the list. Okay, so if you think of it this way, if list X is a train carrying objects, then X double bracket 5 is the object inside train car 5. Whereas X single bracket 4 through 6 are the trains themselves, the train cars 4, 5, and 6. Okay, so if you just say X single bracket 5, it gives you the train car and whatever's inside there. Okay, it gives you the entire car. If you want to go inside the car and see what's inside, then you need to use the double bracket. Okay, so here it says because it can only return a single object, you must use double with either a single positive integer or a string. Okay, so here we've got the list, and it's giving me back the first element, and that will give us the object inside that train car, and same thing over here. And you can use the names for a data frame, because data frames are themselves lists. So you can use double square brackets to get data frames as well. Simplifying versus preserving in subsetting. Okay, so simplifying subsets will return the simplest possible data structure. So we saw this when we subset the matrix, and we said, give me back the first row, and rather than giving us back a matrix with 1 row and 3 columns, it simplified it down to a vector. Okay, if we use the option drop equals false, then that will try to preserve the original structure rather than simplify it. Okay, so for a vector, we're accustomed to just using this. So when you subset a vector, you do this. But there is actually a simplifying version of subsetting a vector using the double square bracket. Okay, list, if you use the single square bracket, it will preserve the list in list form, and if you use the double square bracket, it simplifies it to whatever's inside there. Okay, as far as a factor goes, okay, if you use the regular subsetting operator, it preserves it as a factor, whereas you can simplify it using drop equals true. The matrices, the regular operators function as simplifying versions, okay? But if you wanted to preserve it, then you'd have to throw in an extra option for drop equals false, okay? And then as far as data frames, much like this, it will simplify if you use the single square bracket with the comma to say I want this column or this row, okay? Or I guess really just the column. But if you throw in the option drop equals false, then it will try to preserve it. Okay, so when it comes to simplifying, for a regular old vector, it's the same as just dropping the names, right? So we said most attributes are dropped when you kind of modify a vector or modify a thing, but but the names are preserved. So using the single square bracket will preserve the names, using double square bracket drops the names. With the list, the single square bracket will return it still in list form. The double square bracket returns the object inside the list. And as far as a factor, okay, the single square bracket will preserve all of the original levels inside the factor, whereas if you use drop equals true, it's going to drop any unused levels. So if I have if I subset the factor here, even though there's only the A, it preserves the level B, even though there's no observations of it. Using drop equals true, it simplifies it by dropping any unused levels. Okay, and then for a matrix or array, we saw this behavior, right? So if the matrix is the, if A is a matrix 1, 2, 3, 4, right? Normally, if we just use the regular subsetting operator, select the first row, which will be 1, 3, it simplifies it down to a vector. If you want to preserve it in matrix form, then you say, I want the first row, all the columns, and then you have another comma there with the argument drop equals false. And then that preserves it as a one row matrix with 2 columns. And likewise with a data frame, okay, if the output is a single column, it's going to return a vector instead of a data frame. So that's kind of the idea here. So if you use the single square bracket for the data frame, it will return back your first column in the form of a data frame. If you use the double square bracket, then it returns it as a vector. Because this basically, if you think of the data frame as a list, then this makes sense, because this, if you subset the list with a single square bracket, it returns a list, okay, or in this case a data frame. And then if you subset the list with a double square bracket, it returns what's inside that kind of train car, and that's going to be just the vector. So here, when we look at the structures, we see the difference. All right, is that okay? All of this simplifying stuff here? Oh, I guess I forgot this example. If it's a single column, so if you say data frame comma this column, it normally will simplify it. And if you want to preserve it as a data frame, then you use drop equals false. The $sign is a shorthand operator for using double square bracket, okay? And so here we can do empty cars $sign, okay, $sign cylinder for selecting the column for cylinder. Okay. However, you can't mix the $sign with a character vector. So here I've got the word variable as the character vector cylinder. I can't do empty cars $sign variable. Okay. But if I do want to do something like that, I can. I just have to do empty cars double bracket, and then I use the word variable here. Okay, so this is possible. Like, you can have a loop or something where you're changing out the character vector here to select different columns, but you can't use the shorthand $sign notation. You got to throw it in the double square brackets. So it is possible, but you can't just do this. Otherwise, you would just normally just do empty cars $sign cylinder, and that works out. Okay. $sign does partial matching. Okay, so if you do $sign A, it it will match even though the name is ABC. So yes.
One question about the empty cards and using like dollar sign and it doesn't like look at the characters.
Yeah.
Are names in like are they like character data type?
Yes, names are character data type. So yeah, but so if I do empty cars $cylinder, this selects that cylinder thing. But if I do empty cars $, let's see, does this work? That works. But if I have something where it is a character like this, okay, empty cars $var is going to try to look for, it's basically looking for a column named VAR. Okay. You can, what we want to do is we want to select something like this, empty cars cylinder, or using, so notice if I don't put the quotes in there, then it doesn't work because it's looking for an object called cylinder, which doesn't exist. So this will work if I have the quotes in there, or I can say var, okay? Var here is the character's cylinder, so this works, okay? But empty cars $var tells R to search for a column named var, and so that's why it doesn't work, okay? But these two things are equivalent because the names are indeed character vectors. Yeah. Okay. Is that okay? Yeah, and the $sign does partial matching. So I think if I did empty cars $CY, it still works, okay? Whereas if I did CY here, it doesn't work. Okay, so just if you can match kind of the first couple letters, you're good. But you know, R is now RStudio. As soon as you type the $sign, it starts to it simplifies things, right? So if you type in CA for carburetors or whatever, then or whatever that is, okay, it auto completes for you, so which is nice. Okay, there is a little bit of difference when it handles index out of bounds, okay? So if you give it, so OOB or out of bounds means, you know, you have some object that has, you know, this many rows or this many columns or something, and then you're trying to select something, like your data frame has 5 columns, and you're trying to set, and you tell R, select from the 7th column, which doesn't exist. That's going to give you an out of bounds error, and the way it handles is a little bit different. So if you give R a single something out of bounds, it's going to say missing. If you give it a missing value, it's going to say missing, and if you give it null, it's going to give you a vector of length 0. So if you give it an out of bounds thing for a list, it will return a null list. So all of these things, this, if you use the double square bracket on something out of bounds, it returns back an error. Okay, or double square bracket on the null, some kind of null object, it returns back errors. This is getting really technical, so don't sweat this page. Okay, we can do combine subsetting operators with assignment operators, okay? And so here X is the values 1 through 5, and then I can say reassign objects 1 and 2 in X to the values 2 and 3. And so you can see 2 and 3 have been, the first 2 have been rewritten to be 2 and 3, okay? And then the length on the left-hand side needs to match the right-hand side. So if I say X minus 1, that's going to be objects 2 through 4, or 2 through 5, and then I can say 4, 3, 2, 1 over here, and then that works as well. Always be careful when you do stuff like this. They're nice little shortcuts, but then it's easy to confuse yourself as well. Okay, there's no checking for duplicate indices. So if I say 1 and 1, so this gives me the first object twice, and then I say overwrite it with 2 and 3, basically the 3 is going to overwrite that first thing. Okay? So it gets rewritten to 2, and then it gets rewritten to 3. Okay. All right, and then you can't combine the indices with an NA because now it doesn't know what to do, right? So you can try to put 1 into here, but then you get an error. But you can combine a logical index with an NA, and then it gets recycled, right? So this will go true, false, missing, true, false, missing, and then only the first one and the first and the fourth objects get rewritten with a 1. So it goes true is rewritten, false, missing, true gets rewritten, false, but this one was already a 1. Right, so this is what we have. And so this is probably the most useful time is when you have, if you have a data frame, you can subset the data frame and then modify the ones that fit that criteria. So you subset, these rows in the data frame, and you say, I want to rewrite the ones to 0. So if it's less than 5, we're going to rewrite it to 0, and then it searches through it and it rewrites those to 0. You can also subset with nothing in conjunction with assignment, because it's going to preserve the original object, class, and structure. And so, so in this case, if we do empty cars, empty subset, and then do list apply, empty cars as .integer, okay, it's going to preserve it as a data frame. Okay, empty cars without the empty subset, and we assign the results lapply. Lapply always returns a list. So if we do lapply as .integer, which just turns everything in the data frame into integers, it's going to return it as a list. Okay, because lapply, L stands for list apply, means input a list, output a list, and using this preserves the data frame structure. Let's see. With lists, you can use subsetting and assignment and null to remove components from a list. Okay, so I think we've done similar examples like this already when we were messing around with the attributes. I subset the kind of that list of attributes, and I said attributes $ names or something is null, or $ dimensions is null, or just like any other list, you can subset the list and then and assign the null object, and it just destroys that part of the list. Okay, it just kills it. So here we had a list of A and B, and we said take B, and then now that thing is entirely gone. Okay. If you want to add a literal null rather than kill that element, then you have to use list null. Okay, and then create a list with the null object in it. Okay, otherwise doing this just basically kills that part of the list. We'll probably run out of time to run through all of these important applications of subsetting, but I guess we can get started, and then if we need to, we can finish up on Monday here. Okay, so here you can create lookup tables. Okay, so X is here. I've got a character vector, and maybe we want to define what these things represent. Okay, so maybe we have missing or unspecified or something, and because with subsetting, indices do not have to be unique, and if you ask for the same thing over, it's going to repeat it. So here, every time it sees the M or the F, or the U, it's going to just look it up and populate it. Okay, it doesn't care that that you've repeated the same entry more than once. Okay, so you can kind of have a quick lookup table and produce a basically, so the lookup only has 3 values in it, but when you subset lookup based on this character vector x, now you've got a vector that is has the same length as x, where all of the values in this original vector of only 3 values gets kind of repopulated, or not populated, but expanded to match. Okay. And then if you want to get rid of the things, you can throw it into the function unname. Okay. And you can even do it just straight directly. Okay. Even here, so here we're just going to say known versus unknown or something. Okay. And it's okay that we have repeated known, and we said M corresponds to known and F also corresponds to known, and that's fine. It doesn't matter. Okay. So even though the original vector lookup only has 3 objects, because the subsetting operators allows for repetitions, you can expand that. Okay. We can also match things doing integer subsetting. Okay, and so here the lookup table is very simple, right? We just said, M corresponds to this and F corresponds to this. Here you might have a more complicated lookup table, something with multiple columns, where if the grades are recorded as 1, 2, and 3, okay, you can create a data frame where the rows, where this column is named 3, 2, 1, and then we have columns, of excellent, good, and poor, and then false, false, and true for the criteria failing. Okay, and so when we do that, grades is this, and then if we subset, okay, so keep in mind we are creating this data frame info, which has 3 rows in it. Okay, what we're going to do is we are going to create a match between these elements 1, 2, 2, 3, 1 with info $grade. Okay, so when we do that, it kind of produces these things, and you might ask, why do I get a 2.1? The thing here is that the 2 appears multiple times, right? And to kind of distinguish this row from this row, it's going to say this is 2, this is the first time I see it, and then to distinguish the second time I see it 2, it appends a 0.1. Okay, and to distinguish the second time I see the 1 here, okay, which corresponds to a 3 up here, it's going to say 3.1 here. Okay, so that's what it's doing. So the ID corresponds to the row names, which is 1, 2, 3, and then the grades go 3, 2, 1. So maybe this is not enough example, but you can kind of play around with it and see how this matches. And so we've created a match between this thing grade and a slightly more complicated lookup table that has multiple columns of data associated with it. Okay, so the 2.1, the 0.1 is to distinguish the time it matches the 2, and another time to distinguish it from the other one. Okay, otherwise these 2 rows would look identical. Okay, we'll stop here for now, and then we'll see you guys on Monday.